Hello everyone, welcome back to another video. I'm Math Boy. Today we're going to be starting Chapter 9, Lesson 9.1, and the reason for that is, the title of the book that I'm using, if you remember my intro video, it's not like Algebra 1, it's, Algebra and Trigonometry or something like that, and so it has some calculus ideas in it, and so those chapters, I think 6, 7, and 8. I think those are the chapters. They all are calculus ideas. So we skip those chapters and go to 9.1. Actually, I'm going to do 9.1 and 9.2 today because they're both pretty much a review of systems of equations. Sorry if I sound a little sick. I have a sore throat. It won't be that bad, but trying not to hurt it too much. So let's just jump right into this. So a system of equation is pretty much several equations that use the same variables and equal to different quantities. So like 2x plus y equals 5 and x plus y equals 3. They use the same variables. The x in both the systems are equal, but that's supposed to be a y. The x's are equal in these two equations, the y's are the same, and, I mean, they can't equal the same thing, but there are different, there are equations where the variables in the equations are all the same. And so basically the 9.1 talks about solving these with substitution, 9.2 talks about solving these with elimination. If you don't remember what that is, basically, substitution, you try to isolate a variable in one of them, so I'll subtract x from those sides. So I'll get y equals 3 minus x, and then plug it into this equation. So I'll get 2x plus 3 minus x equals 5, x equals 2, because I combined like terms and brought over the 3. And then you back substitute into one of the equations, and you solve for y. And then elimination, you're technically supposed to add the two equations, but you can also subtract them. And so, I'm going to subtract them here because it's easier, because it's just the same thing as multiplying everything by -1 and then adding it. So you can say if you're subtracting, you're going to want to say you're multiplying everything by -1 and then adding it. So this will be x equals 2 because the y's cancel out, and the x is 2x minus x equals x, 5 minus 3 is 2, and so we get x equals 2, which is what we got earlier. Plug in the 2, one of the original equations, y equals 1. And so I'm going to do a few practice problems. This video is probably going to be really short, just because, this is sort of simple. Yeah, I'll just clear the board. Okay, so one more thing before we jump into solving the problems. If we have something like 2x plus 4y equals 6 and x plus 2y equals 3, if you have an equation like that, we take this equation, divide it by 2, and we get x plus 2y equals 3, and x plus 2y equals 3, which means the solutions are all real numbers, no matter what. All real numbers, of course, along a certain line, but any value for x will have a value for y. So it's not all real numbers, it's infinitely many solutions. And then if we wanted to do something like, and we do this more with the 3 variable systems of equations, but if we want to do something like, I don't know, x equals a, then we can write it in terms of a, so like a comma, because x is a, and then we plug in a here, a minus, wait, what? Oh, plus, because I'm bad at handwriting, a plus 2y equals 3, a equals 3 minus 2y, it's a comma a, no, a comma 3 minus Oh, no, I'm solving for y, not a. Silly me. Actually, you would not set x equal to a. You would set y equal to a if you wanted to be easier. And so x plus 2a equals 3. X equals 3 minus 2a. So then your answer would be 3 minus 2a, comma a. That just means for every value of y, the x value would be 3 minus 2 times that value of y. And if we have a system like 2x plus 4y equals 6 and x plus 2y equals 5, divide the top one by 3, we get x plus 2y equals 3, and I'm not going to rewrite that. In these two, the variable part is the same, but what it equals is different, so it'll have no solution. And that means this system is inconsistent. Inconsistent. I probably didn't spell that right, but you get the point. And that'll be, and then the infinitely many solutions, and 1 or 2 solutions, or 3 depending on how many variables it is. No, the 1 solution, or 2 depending on if it's being squared. That is consistent, and that'll be important on the video I'm going to do later. Well, I mean, they're all probably going to go up at the same time, but the video I'll record after this. So with that said, let's jump right into the problem. Okay, so we have these two equations, and we're going to solve them by substitution, because generally it's easier to solve these with the x squared by substitution. And we already have y isolated over here. If we didn't, we'd probably have to subtract a few things from both sides, or divide a few things, or multiply a few things. But it's already isolated, so we're just going to plug in this value of y down here. And so then we get x squared minus 2x plus 1 equals x minus 1. Subtract x from both sides, add 1 to both sides, x squared. Sorry about that. Don't know what that was. Gotta see if it's too loud. And whatever. X squared minus 3x plus 2 equals 0. And then we factor that, so we get x minus 2 and x minus 1 equals 0. X equals 1, comma 2. And then we're going to plug in our values for y. And then we're plugging in those x values to get our y values. So y equals 1 minus 1. Y equals 0. That's going to be 0. Comma. Y equals 2, y equals 2 minus 1, y equals 1. So our solution is 1, comma 0, and 2, comma 1. Now obviously we would plug that back into our original equation, and, wait, hold on. So, according to my math, oh wait, no, never mind, I plugged in for the wrong spot. Okay, I plugged in x for y on accident. So 0 equals 1 minus 1, that's check. 1 equals 2 minus 1, check. Okay, 0 equals 1 squared, which is 1, minus 2 times 1, which is 2, plus 1. 0 equals negative 1 plus 1, check. And 1 equals 2 squared, which is 4, minus 2 times 2 equals 4, plus 1, 1 equals 0 plus 1, check, and we're all good. So that's how we do it by substitution when there's a power. Now we're going to do a quick one by elimination just so that you get used to it, because trust me, you're going to need it in the next level. Okay, so now we have this equation, and we're going to solve it by elimination. And this is more sort of set up for substitution, but we need to know how to do it with elimination. So we have to get the coefficients of one of the variables the same. I'm going to do x because the x has a smaller coefficient on the top one. So I'm going to multiply this whole bottom equation by 2. So then I get, instead of this, I get 2x plus 2y equals 8, and 2x plus 3y equals 10. That's the same from above. And then I'm going to subtract them or multiply the bottom of my negative 1, then add them. And I get negative y equals negative 2y equals 2. And plug this in back to the second equation, actually, because that one's easier. X plus 2 equals 4, x equals 2, and that's our solution, 2, 2. This is a really short video. Hopefully, won't have our little pink screen problem again, if you know what I mean. But if you enjoyed, please hit the like button. That's the best like button I can draw. That just shows you how bad I am at drawing and art and anything of the sort. So why am I doing this? Like, I have to draw it. You probably don't know what I'm talking about. Hope you enjoyed. If you did, leave a like. And if this isn't the first video you've seen and you haven't hit that subscribe button, please consider doing it. This red button would like you to. Sorry if there's any background noise. I don't know what happened in the bathroom next to me. But see you guys next time. Bye. Oh, and in a future video, I might be doing a collab with one of my good friends that I know. There. We're playing Hangman. Okay.